Okay, so on this problem, it looks like from this diagram that this is kind of concrete, probably reinforced concrete, so it looks like it's cast as one solid piece. So if you look down here at A, what kind of reaction do you think this is going to be? This looks pretty much like a fixed support. You'll notice here at B that it's also fixed. But if you look at the whole structure as a single free body diagram with only 3 unknowns at A, 3 equations, 3 unknowns, you're good to go. So we'll start like we did before. Let's draw the free body diagram for this thing. So I'll make a line drawing. Kind of gives the basic geometry, and I'll rewrite it there so we don't forget. So this is 12 feet. This little overhang is 3 feet. This is 10 feet high. Now at the bottom here, I'm going to assume that I have a vertical reaction in the y direction. I'll call that AY. I'll have a reaction in the x direction. Call that AX. And then I'll assume that I have a moment. And since I like to use right-hand rule, I assumed all these in my positive sign convention. But right now it's completely arbitrary. You can choose any way you like. You'll find as we move along, I'll always choose it this way. We have an applied force out here on the end of 5 kips, so let me bring that down. And now we have a distributed load across the whole top edge of this roof system. It's rectangular. That's great. We know the area of a rectangle. It's the base times the height. Now the base of this is going to be 3 plus 12. It looks like that's 15 feet. And the height is this intensity of the load, which is 0.6 kips per foot. So that's 9 kips. And it's going to act in the centroid of this. So I'll draw it on my free body diagram as an equivalent force of 9 kips. And the total distance here was 15, so it's going to happen right in the middle. So that would be 7.5 feet on that side and 7.5 feet on that side. I think that's mostly what I need to do the job. So there's my free body diagram. Okay, pretty simple. You might recall from your statics course, you probably worked a little harder problems than that, but just to kind of get us going again. Now, where should I begin my equilibrium? Should I sum moments at B? I can. What will that give me? It'll give me one equation in what? What creates moment about B? Does AY create moment about B? No. Does AX create moment about B? Yes. Does this moment create moment about B? Yes. So I got one equation, 2 unknowns. That's not good. Yes?
Do we do sum of forces in Y?
You can do sum of the forces in Y. Because I only have one unknown Y, I can get that. Could I sum forces in the X first?
Yes.
I could. So the only thing I'm left with is the moment at A. So if once you found AX and AY, you could sum moments at B. You could sum moments at C. You could do anything you want. My suggestion to you, though, is to not incorporate previous answers into your equations if you do not have to. Because if you make an error, it's just going to propagate through your whole solution. So if you don't have to do it, don't do it. So how can I find the moment at A and not include AX and AY? Some moments at A. So I'll get one equation, and I'll be able to sum for the moment at A, and it doesn't matter what AX and AY are. The previous strategy, right, where I found AX and AY and then some moments at B, I would incorporate those solutions for AX and AY into my solution for the moment at A. And that could lead to some error. So I suggest the path of least resistance. So we're going to sum moments at A. So again, I'm going to assume right-hand rule. And we will sum moments at A and set it equal to 0. So again, using right-hand rule for my sign convention, I'm at A. What kind of moment is A? It's positive. So there's MA. What else creates moment about A? Does this 5 kip force create moment about A? Yeah, it does. Is it going to rotate clockwise or counterclockwise? Clockwise. Well, that's opposite of this, so that's going to be negative moment. So I'm going to have a negative moment created by a force of 5 kips. And what's the distance between A and the line of action of the force? It's the height, which is 10. So there's the moment about A due to the applied force. Now what about the concentrated equivalent force? Is it going to create moment about A?
Yes.
Positive or negative?
Negative.
Negative again. So it's going to be a negative moment. The force is 9 kips. What's the distance between A and the line of action of the force? It's this little distance right here.
4.5.
Yeah, it's going to be 7.5 minus 3, or 4.5. And that's it. So when I solve for moment at A, what do I get? 90.5. Anybody else get that? Mr. Jafari, I see your fingers rapidly. Anybody else get it?
Yeah.
Yep. Okay. 90.5, and that'll be kip feet. It came out positive, so that means this is the correct direction of the moment. Does that make sense? Well,
Yes.
think about A, and all these forces are going to cause this structure to do what about A? Rotate which way?
Clockwise.
Clockwise. So the moment responds opposite, counterclockwise. So what are we going to do next? We need to find AX and AY. Which one do you want to do first? Does it matter which one we do first? No. So I'll do Y first. I don't have a reason for that, except that I've already started it. So I'll sum forces in the Y direction, make sure it's equal to 0. So sum of the forces in the Y, what do I have? I have AY, it's up, and up for me is positive. So there's AY. What else do I have? I have this equivalent force 9, it's down, so that's negative. That's not a hard equation to solve. So AY is equal to 9 kips. And then last but not least, we'll sum forces in the X direction. I'll assume to the right is positive. And let's see what we've got. Well, I assumed AX in this direction was to the right. So I'll write that, AX. I look at all my other forces. I have an X component force. It's also to the right, so it's positive. So in this case, when I solve for AX, what do I get? Minus 5 kips. What does that mean? It just means it's the opposite direction. One thing some students get concerned about is they think negative is like, if you look on a number line, negative values are less than positive values, right? In structures, the sign is just direction. We care about the magnitude of the value. So is a minus 5 worse than a positive 5? No, they're both 5 kips. You still have to do it. It's just the direction that you have to supply the reaction in. You have to be careful, too, if you do this kind of stuff in Excel and you say, hey, let's take the max or the minimum, it's going to think negative values are always smaller than positive values. So you've got to remember, in structures, it's the magnitude that counts. That's a pretty simple one. So any questions about that one?
I have a question.
Yeah.
So I do the clockwise is positive for the moment, so I got a negative 90.5. So as long as
You don't have to do anything.
noted my direction.
If you drew here that your moment was clockwise, that's fine.
So, as long
So
as
that's a
you
good-
know which way I'm using.
So what I'm going to do is, when you work this problem, I'm going to look at your Freebody diagram. All right? Yours does not have to look like mine. Well, parts of it should look like mine. But these parts here, you could assume every one of those in a different direction. All right? But I'm going to look at that. And just like you said, if you assume clockwise and you get a negative, that's fine. That's still the correct answer. What I don't want you to do is run back over here, erase it, change the direction, and then leave the negative 90 up here, because then that is wrong. So once you draw your free body diagram, unless there's a catastrophic error, you forgot something or you missed a dimension, don't mess with it. Once you make these assumptions, just leave them alone. You'll also find, I'm sure you already know this, that in the confusion of the exam, the less you have to consider, the best. So if you train yourself just to make assumptions and just go with it, then you don't have to second guess. You don't have to get halfway through the problem. You see the timer ticking down. I'm running out of time. You're already nervous. You're already stressed. And you make a dumb mistake. Well, are all mistakes dumb? No. But you make a dumb mistake. So try not to do that.